How are you guys doing? Have you enjoyed the week? It's been awesome for me. I grew up in Virginia. I live out in Portland, Oregon now, so it's really nice to be back. And it's been an interesting couple of days. I've really enjoyed the sessions. I hope you have as well. Just a little bit about my journey. I started off as a computer scientist. I went to UVA, and then for many, many years I developed software for airplanes, so avionics software. And quite a bit has changed since those days, but one of the things that I remember very vividly is that one of the largest projects I worked on was a collision avoidance system. So if you fly a commercial airliner today, you're going to be flying with this equipment in the aircraft, and basically what it does is communicates with other aircraft in the region, and it ensures that no one crashes into each other midair. So as a software developer, of course it was buggy in the early days. We didn't trust it, especially the software developers didn't trust it. It would basically, works with the radar display in the cockpit, and it will show you all the airplanes in the vicinity, and if it's predicting that a couple are going to crash or come close to crashing, then it'll issue a warning. So I remember our very first set of flight tests, and of course, nothing went right. We had aircraft flying towards each other. I was in one aircraft, other developers were in the other, and it was telling us to climb and telling the other to climb, and it was a big disaster. I mean, not a physical disaster, but from a software testing standpoint. So, the testing went on for months and months, and I just didn't have much confidence in the system, and that might be because I was contributing a lot of code, but eventually we got to the point where we were doing some of our final flight tests, and we had to go out to the LA basin because that's the heaviest air traffic density in the world. And I remember the first time we went up in the air, we had our test equipment on the aircraft, and we're kind of nervous because this was one of the final sets of tests that we needed to do to get certified by the FAA. And for the first hour, air traffic control knew what we were doing, so they would give us warnings. They would say, okay, you've got a plane 200 feet below you to the east, or a plane 500 feet above you to the west, and our equipment was saying like the opposite. So we're going, shoot, this is supposed to be our final test, and we just didn't trust it. Well, after 2 days of testing, what we realized is that it was air traffic control that was wrong all the time, and it was our equipment that was correct. And that's when I realized I trust this software. And for the last 25 years, I've trusted that software every time I've climbed aboard an airplane. And it's interesting. So I come from a software development background where trust of software is extremely important. We kind of move into the 2019 era, and software is really different. And there is an aspect of security around software that I think a lot of organizations ignore. And that's code signing. That's what I'm going to talk about today. And I'm interested, before I get started, how many of you work in an organization where the organization, there's a development team and you're developing software that gets delivered to a third party like a customer? Just raise your hands. Okay, how many of you work in an organization where you develop software but it's critical for the internal infrastructure? So accounting systems, financial systems, that sort of thing. Okay, so software plays a big part of your organization. You probably have web servers, right, with software running that might interact with the public. So why should you care about code signing, especially from an InfoSec perspective? In most of the organizations I work for, code signing is something that the development organization is responsible for usually. But if you're focused on risk for your organization, and trying to protect against those risks, then you're going to see in my presentation today why this should be top of mind for you. Code signing has been around since the 1990s, and I'll go into a little bit of the history just to put everything into context in just a few minutes, but I just wanted to start off with the case study. This happened just a few months ago. Everyone's heard of the Zeus computers. It's a brand of computer. And Kaspersky Labs, they write antivirus software. So in 2019, Kaspersky discovered that a bunch of Zeus computers that were installed, at various customer sites were infected with a malware called Operation Shadowhammer. And basically, this is what happened, is that, as you know, Windows pushes out live updates to computers, and some people love that, some people hate it. Well, ASUS does the same thing. They have updates to their firmware, to their drivers, et cetera. and they automatically push those out to all of the computers belonging to their customers. This is done maybe at night in the background. No one really knows what's going on. And those computers trust that software because it's been code signed. And if you aren't familiar with the term code signing, I'll go into that in a little while. But the important thing here is that there's a level of trust between what ASUS was doing and the software that it was pushing down to all the computers of their customers. So what happened in this particular case? ASUS would sign those updates, code sign those updates, on that web server. And as I'll explain in a few minutes, when you code sign something, you need a private cryptographic key as well as a certificate. And for whatever reason, ASUS was storing those private keys on that web server. And what happened? Hackers broke in. And who knows what their original intent was, but once they discovered that there were private keys on that particular server, they basically took a legitimate update that ASUS was going to push out to its customer base, and they inserted malware into it, re-signed it with the ASUS valid private key for code signing, and then what happens? That got pushed out to ASUS's entire customer base. Everyone assumed it was legitimate software coming from ASUS. No one suspected that it contained malware, and it infected 1 million computers. This is just one example that shows how important code signing is to an organization. And it doesn't matter if you're developing software that gets pushed out to customers, or developing software, or your organization develops software that just gets pushed to a web server, it's a web service, or it's software that's used internally. Maybe it's software that you've purchased from a third-party vendor, and you use it internally. How do all of your users know that that's really the legitimate software? And that's what code signing is all about. In terms of business impact, on ASUS, it's pretty significant. You know, from their customers' perspective, they pushed out an update that contained malware that looked like it was valid, and their computers automatically installed it. So that could hit their revenue, hit their market share. There could be liability issues, but it's very significant. And this is why, at least from my perspective, you know, I think about trust in software, you know, that we have that physical trust with that collision avoidance system, and then we have the trust that we have today with web services and software that's pushed out through the internet. That has to have a level of trust as well. And it's just the latest incident. I mean, this has been going on for years. Hackers are selling legitimate code signing certificates on the dark web, and they're spreading malware with it. You can actually buy these certificates for, you know, they're fairly reasonably priced, anywhere from a couple of $100s up to $1,500. And according to a McAfee vulnerability report a few years ago, or I think it was last year, there have been 22.5 million instances of malware that's been signed with either stolen or forged code signing credentials and certificates. So the threat's real, and I really wanted to start off the presentation today talking about how real this threat is, especially since there are many organizations where InfoSec is not part of that process that's trying to protect those code signing certificates. So I asked you a few questions earlier. How many developed, worked for organizations that sold software or provided to third parties or used it internally? And basically every business today is a software business. It's either your product that you sell, it's something that you use internally that's critical to your business infrastructure, or it's a way that you're transforming the services that you provide from physical services to more digital services. So code's critical. And if you aren't aware of that risk that it poses to your organization, you need to become aware, and that's really what I hope you get out of today's presentation. So I'm going to cover a couple of things. Talked about the risk already, and I hope everyone takes those seriously. I'm not sure how many of you understand what code signing is, so I'm going to just spend a few minutes talking about what it is, the history behind it, and you know, it's been around for a long, long time, so why is it kind of raising its head now? 5 common challenges that organizations like yours might face, and then I'm going to end up with 5 best practices. I work for a company called Venafi. I promise this is not a product pitch. This is purely informational and educational. And let's get started. So what is code signing? It's basically a technique that uses a certificate-based digital signature that signs a computer executable. And it does two things. It verifies the author's identity. So if I say that I work for Microsoft and I develop software for Microsoft and then that software gets signed, it says that it comes from Microsoft so that if you see it, you know that it comes from Microsoft. It also ensures that the code's not been changed since it was first signed. So if you think back to ASUS, what happened? They didn't protect their private keys. So hackers were able to access those keys, and then they were able to sign on behalf of ASUS, and they were able to insert malware and sign after that, so it looked like it was valid. So this is really, think about this. It's an information security risk if those private keys are not protected. You also think about code signing certificates. They're like birth certificates. So if a birth certificate's stolen or if it's forged, it can cause some damage. Code signing certificates obviously can cause a great amount of damage, especially to our organization. And even though this is a technology that's been around for many, many, many years, these certificates and the private keys are more vulnerable than ever because hackers have, you basically plug up one hole and what do? They try to find another vulnerability. So they've now discovered, okay, if we put out a game on the internet and it's really disguised malware, no one's going to download it unless it's been signed with a certificate from a company that someone trusts. So what do? They go and start trying to steal those certificates and keys. So when we talk about code, what do we mean by code? Obviously, what comes to mind is that computer program that you install on your Windows machine. It could be a driver that goes onto that computer. It could be firmware that lives in the hardware. It could be a mobile application on your phone. One of the things that's so great about the Apple ecosystem is that they do a really good job of preventing malware-infected apps from getting installed onto an iPhone. Shell scripts. So, if you work in IT, you probably have lots of automation where you've written PowerShell scripts or members of your team have written PowerShell scripts. Because it's automated, if those things are not protected, someone, say within your organization, could modify those scripts and no one would know the better. So it's a great opportunity to be able to sign that shell script to say this is trusted, we know it's not been modified. Finally, there are operating systems and then application containers, which if you're familiar with some of the virtualization activities going on and the trends towards the cloud, this is going to become more and more important. So those things need to be trusted as well, and we would consider them code. So this is all types of code that can be protected by a code signing certificate. So how do you actually sign code? And I don't want to get too far into the weeds, because mostly, as I said, this comes from the software development team, but you start off with code, and you use a tool that's usually provided by the development tool stack. So if your team's using Visual Studio, or if they're using Java, or they're using Apple Swift, part of the tool set that those suites come with includes a code signing tool. And basically, the first step of what that tool does is it generates a hash of the code. So with a hash, we know that this is the state of the code. This is what all the bits and the bytes of the code were when it got submitted to the code signing tool. Then you provided a private cryptographic key that's used to create a signature of that hash. So it's encrypted now. And then the code signing tool takes that signature, combines in a code certificate with the original executable, and out pops signed code. So that's the process of what happens when we sign code. So it's really simple. It's just a command line tool. Or if you're in Visual Studio, it's a drop-down menu item, and you say sign this. Or if you're in Swift, it's the same thing. It's pretty simple. So that's why developers tend to do it. But what's critical here is that cryptographic private key. That gives you keys to the kingdom, to your whole business. If someone gets a hold of that key, they could sign anything, just like we saw with the example of ASUS. They got a hold of a private key that should have been more securely managed. They were able to modify and update, add their malware, re-sign it, and to the world, it looks like it's perfectly valid product from ASUS. So why do we sign code? So there are two scenarios. One is that you're trying to protect code that you need to distribute. So you want to protect your customers. You want your customers to be able to trust what you've provided them. You want them to know that, yes, this did come from you, and no one has modified it since you last signed it. It also protects your business, because you don't want cyber criminals signing code on your behalf that turns out to be malware or worse. There's another scenario, and this might apply to more of you than the first one, and this is you want to protect your business. So this is code that you use internally. Maybe it's those shell scripts that help automate some of your processes, or maybe it's a database system that's only used internally, or your HR system. But basically you want to be sure that when you bring it into your organization and you run through your acceptance test, you are able to sign that and say, this is now blessed. We know that this is trustworthy, and if anyone in the organization installs it, they can check to see if it's been signed by your organization to say that it's trustworthy. So it's a great way to provide that internal trust within your infrastructure. So brief history, I've talked about this. Why does code signing exist? Think back to the 1990s. And software was first being distributed on the internet. It's great. No more floppy disk, no more CD-ROMs. Actually, CD-ROMs were around for quite a while after that. But basically, it was a way to get that software from the vendor to a customer. And at some point, malicious actors, hackers, whatever you want to call them, they started putting their own stuff up on the internet, and this contains spyware, malware, viruses, etc. And the consumer, the user, had no idea which is good, which is bad. So the solution in the 1990s was to do code signing. So code signing, basically you get a certificate from a certificate authority. You use that to sign your code. That signed code goes out on the internet, and then if someone downloads it, they know that's safe. If they see software out there that's not signed, or it's signed with a certificate that seems to be suspicious, the consumer would know that's not safe. And when I say consumer, it's either a conscious decision, or it might be the operating system making that decision, that it sees a certificate that it feels is not safe. So what did hackers do? They responded. They responded by going after the certificates themselves and the private keys. They would steal them, or they would forge them. And now their malware looks just like valid software, and to the average operating system or the average consumer, they have no way of knowing which is the correct one. So it's a new problem in the late 2000s here, 2019, and it's all around securing those certificates. So we have the technology that secures the code, but if you don't protect the certificate and the private keys, it's like basically giving out the front door key to your house. And when you think about the complexity of organizations today, back in the 90s, it might have been 5 software developers developing a program that would basically fit on a floppy disk. Now we're talking about huge programs developed by thousands of developers. We work with some customers where they have 30,000 developers in their organization. They're all responsible for signing their code. That means hundreds or thousands of certificates. And if everyone manages their own private keys, what happens? They aren't safe, they aren't secure. The other complexity is that software now it's now heterogeneous. So you have web services for an application along with the mobile app, along with the back-end infrastructure for that app. And you have lots of different software development teams all working towards a common goal, but they're using a different set of tools, different environments, needing different code signing certificates. So it really becomes a complex project to manage. And then, no longer are we in the days of waterfall where everything was really controlled. You do requirements design and coding and testing and so forth, but it's all done in an iterative process, either through DevOps processes or Agile, which means the goal is to get things out as quickly as possible. And as InfoSec professionals, you really need to step back and say, hold on. We realize that you have a goal for getting things out quickly, but let's make sure that it's done safely and that we're trusting and we're securing those critical credentials that can basically give cyber criminals the key to our business or organization's front door. So how do organizations cope with this issue where you have thousands of developers, thousands of code signing operations? Well, there's one way, and that is basically they request a certificate from the InfoSec team. The InfoSec team says, okay, we're going to go out to the certificate authority. We've done all the work for you. Here's your certificate. Here's the private key. Please keep it safe. Goodbye. Good luck. Have a great day. Another way is that the InfoSec team says, no, we don't trust the developers. We know how sloppy they are. They might be great software developers, but they really don't know about security. So we're going to keep all of this stuff for ourselves in our own personal vault. And so they're asked, okay, I need to have my code signed. They're going to say, okay, sure, take a ticket. We'll try to get back to you next week or next month. We'll get that signed and return the signed code to you. Both of these have issues and problems. On the left-hand side, you end up with insecure private keys because you have all of these keys residing on developers' laptops, build servers, in ASUS's example, web servers. And on the right side, you have an issue where the development team just hates you because you can't turn around their requests fast enough because you just don't have the bandwidth for that. So it's just too slow, and then they get annoyed and frustrated, and you need more resources to handle all of this. So there has to be a better way. So let's talk about just 5 common challenges. And I'm curious, how many of you deal with code signing today in your organization? And is that all handled within the InfoSec team, or is it handled by the development team? Who keeps the certificates? Developers? And what about InfoSec? Okay, so that's pretty scary. So let's talk about what some of the challenges are that you have to be aware of. First off, you got an issue with private key sprawl. If you have one developer, one code signing certificate, it's probably easy to keep track of. If you have 10, maybe that's easy to keep track of as well. You have a spreadsheet. But when you have thousands of developers, thousands of certificates, tens of thousands of signing operations a week, how do you keep track of that if all of your developers keep those keys wherever they want to keep them? Do you know they're secure? I mean, this is a huge risk. I sat through the 101 risk session earlier. This is a just huge threat and a huge vulnerability if you don't keep track of those private keys. Because if anyone, either within your organization or outside of your organization, gets a hold of that key, they can cause a tremendous amount of damage by distributing malware or other software in your name, in your company's name, without anyone knowing the better. Do you know if any of those keys have been compromised? Maybe someone's laptop got stolen and they had those private keys on that laptop. And then do you know who in your organization has access to those keys? So if you don't have that visibility, this is a real challenge for you to be able to do your job in protecting this critical business asset. The next is lack of visibility in what's happening. How many pieces of code get signed a day in your organization? 5, 10,000, 10,000? We work with one customer that signs, I think it was 5 million pieces of code a week. That's a lot of code. It's a huge company, but it's a lot of code. Where do those certificates come from? You know, you don't necessarily want just a developer going out and signing up with any old certificate authority to ask for that certificate and get that certificate themselves. You really need to be part of that process. Is the code internally signed, meaning that is it okay for internal use, or has it been signed with a certificate that makes it okay for distribution externally? And then who is actually responsible for signing it? Most organizations have a particular process. Hopefully they have a process that says only these individuals are allowed to sign code on the behalf of the organization. Then you have an issue and a challenge around lack of governance. Do you have code signing processes defined? So you probably have processes defined on how you handle TLS, SSL certificates, how you handle security going in and out of the office, but do you actually have a process defined for how your company handles code signing certificates? You do have a process, and hopefully you do. Do you know, is there a compliance with everyone that does code signing within your organization? Are they complying with that process? If you specify that only certain people are authorized to sign, how do you guarantee that only those certain people are authorized to sign? Or do they get the proper approval to be able to sign in the first place? How do you know if they're actually using the right certificates? I mean, it's also, it could be extremely bad if they use the wrong certificates or they use that certificate in the wrong way. So lack of governance and control over signing creates huge risk for your organization. And then we go to lack of automation. And if we think back to that example where someone comes to you with a floppy disk and they say, I need to have this code signed, and you have to go through your files and figure out, okay, where's that certificate at? Where's that private key at? You type in some commands. You first put it in your work queue. A few days later, you get to it, you sign it, you hit that floppy disk back over to that person. That's really inefficient. It's time consuming, and it requires a lot of resources, and it's prone to error. So you really, if you have a lack of automation, you have also a significant problem in your organization around code signing because it happens so frequently, especially in DevOps and agile software development environments. Developers also are probably using extremely automated tools for doing their builds. So if you don't have that code signing process built into their workflows, they're going to find ways to work around it, and that's something that you really don't want to do. And then this next challenge is your group isn't involved with code signing. So your group's responsible for risk and security of the organization, but yet it's not involved in code signing. So huge problem, but maybe even a bigger problem is that your group's the bottleneck. So everyone's complaining about you just slowing down that release. The release didn't get done last Friday the way it was supposed to because it didn't get code signed until Monday. So if that's happening, that becomes a big issue for your organization. So those are the 5 challenges. And you know, the digital signature is no longer enough. Just the fact that you've code signed something doesn't necessarily make it trustworthy if you haven't secured those certificates and those keys. So if you're to go back to your organization and do 5 different things, you may not be able to do all 5 of these, but these are things to consider. What would those be? And I'm going to run through each of these in more detail, so let me just get through this and then start on this one. Centrally secure all private keys. There should be no reason that a developer has a private key on their workstation. If you've ever been to their cubicle, they're usually pretty sloppy. They've got other things on their mind. They aren't PKI experts. They should not be stored on someone's private personal computer. As we saw with the case of ASUS, they should not be stored on a build server or a web server. Those things could be hacked into or accessed by someone who doesn't have the authorization. You really need to come up with a system to where all those private keys are centrally stored in a very secure way. And let me just mention, when you store them securely, what I mean by that is either you store them in an HSM or you store them in an encrypted format in an encrypted database. But basically, you want to limit access to those private keys. And this goes across the entire organization. So if you have satellite offices around the country, you don't want every one of the satellite offices to have private keys stored locally, and so you want them to be stored centrally. You want to know who, what, where, and when. So if you can't answer these questions, and this is probably one piece of advice if you go back to your organization, ask these questions. How many code signing operations are in use today? Do you know what that answer is? If not, then there's a problem with visibility. If you found malware on the internet that was legitimately signed by one of your company's code signing certificates, would you know which group to go to track down how that might have gotten out into the wild? If you don't have track over who has what certificates, who's using what certificates, you can't answer that. If you have developers working directly with certificate authorities, would even know where to start looking. I mean, most organizations, they work with a very finite set of certificate authorities. Do you even know who's actually code signing? Is it just this one team, or is it all of these teams? If you have a team that's working on critical infrastructure, software infrastructure, and they are not code signing, that's a problem. You should at least be aware of it and offer assistance to change that, because it's going to decrease your company's risk. And if there was a need for a compliance report, maybe your company's being audited, would you be able to tell them who has signed what, when it got signed, what certificate was used, etc.? Those are all very important pieces of information that you should know as an InfoSec team. So you always want to have an inventory of code that's been signed. Know every piece of code in the company that has been signed. You should be able to report that. Know who signed it, know which certificates were used, know who approved that to be signed, and that implies that there should be an approval process. Know when it was signed, and do this for everything in your company where software assets are either developed or they're purchased and then distributed internally. So the next best practice is control access and define workflows. So if you're a financial institution and you have some very significant regulations to comply with, there are some requirements for what those processes should look like. So you need to be able to define a process that protects that code signing asset and enforce a workflow. So it needs to go through this sequence of approvals before that certificate can even be used. You need to define who has access to that particular private key, who has the rights to say that that person can use that private key. And one size might not fit all. So this particular project may have this set of needs, this other project may have a looser set of needs, a less restrictive set of needs. And you want to be able to create different kinds of workflows and be able to support different kinds of workflows. You don't want to have, if you have a relatively benign piece of software that you still want to protect, and you don't want to make them go through the same rigorous process that your critical infrastructure team needs to go through. And again, automation is key to doing this. If you don't have a way to do this through automation, it's going to be hard to get developers to embrace what you're doing. So this next one's really interesting. You know, as I said, I come from a software development background, and I remember kind of pushing the security team off to the side. You know, I was concerned, don't get in my way. You know, I know what I need to do. And so sometimes there's friction, and especially around code signing, there's going to be friction. So you got to think about this. And the last presentation, if you were in here for this, I think the gentleman made some really great points about thinking about their perspective. Do they think that your team slows them down? Maybe they don't see the value in what you're trying to do by protecting that asset. Do they look at you and think, well, you're just giving us more rules that we have to follow? Do they resist trying to do things better in a more secure way? What you need to do is you have to switch the conversation. Instead of saying, you have to do this, you have to do this, you have to do this, fill out this form, do this, et cetera, et cetera, et cetera, you should provide value to them. So remember, the development team, they're not PKI experts. They know they have to sign code, they know they have to deal with certificates. It's a must-do, it's not that they want to do it. So if you're able to provide an automated service that allows them to do this in a very frictionless way, you're going to become the hero for that development team. So it's going to create a good situation. But to do this, you have to kind of know what their priorities are. So if you think about a development team, their number one priority is to get quality code out quickly. They have a very complex environment because they probably have multiple development teams, multiple software development tools. They're using different programming languages. If you ever talk to a software developer and say, can't you just change that tool and use this instead? They're going to hate that because they get so attached to their tools. It's funny, and I'm embarrassed to say that I'm like that as well, that I have a particular set of development tools that I like, and I don't want anyone telling me that I can't use those tools. They don't want to be slowed down with extra processes, especially when they don't see the value in them. And as I said, they aren't CS or code signing or PKI experts. So that's what you should know about the development teams that you're trying to work with. So what can you do to kind of reverse this instead of saying you have to do this? You can reverse the conversation and say, hey, I can help you do this. So you want to offer them a platform or a service that adds value for them. So you want to make sure that it seamlessly integrates with their development tools. So if you're making them pull out certain tools that they're familiar with, that's not a good choice. But if you're able to work in a solution that allows them to continue to use the tools that they already do, they're going to like that. They're going to say, hey, it's no big deal. It's just like before, so sure, we'll add this. You want to be sure that it doesn't slow down that process. So some code signing tools require that you upload the executable, the code, to a cloud server, gets signed there, and it gets downloaded. So that's really easy for a 1 megabyte piece of code. But when you're thinking about a piece of code that might be a gigabyte, that takes a long time to upload it, and it takes a long time to download it. So developers don't like that. So come up with a solution that makes that go as fast as possible. And then basically you say, hey, no longer do you have to deal with all the certificates yourselves. You don't have to worry about where those private keys are. You don't need to remember which ones to use, which ones not to use. We handle all of that for you, and it's going to be done seamlessly and automated. They're going to love you. They're going to say, this is a great service for our team. It's going to be a win-win situation, a win for security for the company and a win for the development team. And you want to be able to show compliance. So if you follow those previous strategies, you're going to end up with keys stored in a secure location, central location. They're safe. You know that no one can get to them that's not authorized to get to them. You're going to know the who, when, what, and why. What got signed, who signed it, when it got signed, what certificates were used, all of that. So that's a great audit trail set of records. You're going to be able to define workflows that can be implemented automatically. And that's going to allow that whole process to go very fast, and it's going to also prevent people from bypassing that process when it's automated. And you're going to know that development teams aren't straying from what they should be doing because you are providing a service or solution that adds value for them. So they're looking at you as a source of, you're making my life better instead of you're making my life worse. And then you can create a compliance report if you do all of these things to say, yes, we have a code signing policy, we've defined how we're going to enforce it, and we have proof that it's been enforced company-wide. So I know I've covered a lot. I hope some of the early stuff about code signing wasn't too basic, but I know at least with other groups that I've spoken to, not everyone's familiar with code signing, especially since it often happens within the development organization. But really the primary thing is that as InfoSec professionals, this is a really important aspect of your company's business that deals with any kind of software. Software that's developed and used internally only, or software that's sold as a product. You have a set of challenges that you need to be aware of, and then there are some best practices that you can start to follow that can help you address those challenges. So thanks a lot. If you have questions, I'm happy to answer some questions. You can reach me either at Twitter or my email address. I didn't talk about my company, and I did that intentionally, but if you'd like to find out more about what Venafi does, obviously we help with machine identities, including code signing certificates, TLS, SSL certificates, SSH. I'd be happy to talk to you about that as well. But for now, are there any questions? Right, so that's what developers want to be able to do, to integrate with those tools. So when you do select a service or a solution that helps automate that process around code signing, it's imperative that those fit into those tools. So, be it Chef or Jenkins or whatever, that solution needs to basically have an API that allows those keys to be pulled in automatically from that secure storage and secured, but in an environment that can support that kind of development. Any other questions? Okay, well, thanks a lot.